What is science? Science is creating models of reality. We take the data that we have and we say maybe this is what things look like in actual reality. Now, when we're dealing with atomic chemistry, none of this happened by just people looking at atoms. Even now, we don't have the technology to look directly at atoms, certainly not to look directly at electrons or anything like this. So, when we were trying to figure out the structure of an atom, there were a lot of different models that happened. Here's one early model of an atom. So at this point in history, people discovered that there was something they called an electron. They originally called it a cathode ray, and then they started calling it an electron. And they knew that it was negatively charged. And they also knew that negative charges repelled each other. So they figured that there was some kind of a positive charge stuff surrounding the electrons, and the electrons are basically kind of coated in this positive charge stuff. It's called the Plum pudding model, and it's basically like you have a big old bowl of pudding. The pudding is the positive charge stuff, and in it there's some plums, and those are like the electrons. Then the Rutherford did the famous gold foil experiment that showed that the plum pudding model was actually not accurate, and that's because of this experiment. Well, let's actually walk through this experiment. So you have a radioactive source inside of a lead box, and it's sending out alpha particles. You'll learn later on what those are, but they're small positively charged particles. They're two protons and two neutrons. The two protons and two neutrons together makes up an alpha particle. So these alpha particles can only come out through this hole, so they come out in this line here, yes? And then they hit this gold foil. Now, if that plum pudding model was true, then any alpha particle that went through this gold foil would be kind of deflected a little bit by the positive charges that made up the pudding of the plum pudding model. But that's not what happened. Most of the alpha particles just went straight through with no deflection at all. But some of them were deflected a lot, and some even just bounced right off and bounced backwards. Rutherford realized that in order for something to be able to just make an alpha particle bounce back off of it, it would have to be a pretty massive pile of positive charges. He called that the nucleus, and today we think of the nucleus as being the protons and the neutrons in this positively charged nucleus that's at the center of the atom, with the electrons kind of going around it. Now, so far, and that's how we got that model that you're used to, with the nucleus, the center like the sun, and the electrons orbiting around the nucleus like planets. But then, since then, people have done a lot more experiments. And as it turns out, not surprisingly, the atom is a little bit more complicated than what we originally thought. It's not as simple as electrons orbiting the nucleus. Oh no, it's a little bit different than that. Now, I'm going to show you what we currently think an atom looks like, and you need to try to not freak out too badly. Here's what it actually looks like. We have each of these things are called orbitals. Here's this little blue thing, this blue sphere over here. This is called the 1s orbital. And s orbitals are always spherically shaped. And we say that the electrons in the 1s orbital can be found anywhere in this sphere. And they don't have to go necessarily in a circle. They can go in any direction, but they're usually in this spherical region. Atoms in the 2s orbital are in a slightly bigger sphere. And again, they can be anywhere in that spherical region. Now, you have something else called the p orbitals. And p orbitals look like this. This whole thing, this top and bottom lobe, all represent one p orbital. These two lobes here represent another p orbital. These two lobes represent another p orbital. So we're going to start to explore orbital theory, and even something later on called hybrid orbitals, as we start to develop a modern view of the atom based on the more advanced and more recent information that we're using to create this more accurate model.